Request to all head of department, please come on the dais. Principal sir, Parvane sir, please take a seat on the dais. Okay. Good afternoon, one and all. Myself, Sagar Tambe, Professor, Computer Department, PRC Sidori. Today we are gathered for the seminar on artificial intelligence and machine learning. On the behalf of Computer Engineering Department, PRC Sidori, I welcome you all here. As per our tradition, I request all dignitaries on the dais to proceed toward the lamp lighting ceremony. Thank you all respected dignitaries. Now I request to Mr. Jamal Patil to introduce today's guest of honor, Dr. D. Datta.
Good afternoon, everybody. Today, we are all fortunate enough to have amongst us a galaxy of distinguished scientists from Baba Atomic Research Center, Mumbai. I feel privileged to introduce today's guest of honor, Dr. Dr.Vithalrao, who is working in the capacity of Scientific Officer H+ and Head of Radiological Physics and Advisory Division of Health, Safety and Environment Group at Baba Atomic Research Center, Mumbai. He has high academic credentials, which includes MSc in Nuclear Physics from Kolkata University, MPhil in High Energy Nuclear Physics from Saha Institute of Nuclear Physics, Kolkata, graduation in the field of Nuclear Engineering from OCES Training School of Baba Atomic Research Center in the year 1984. He also has, to his credit, a PhD in Computer Science from Mumbai University in the year 2000. He has proficiency in software development using soft computing techniques. He has developed a large number of softwares in the field of radiation protection, safety, and uncertainty modeling. 3 softwares developed by him has been exported to Turkish Atomic Energy on their request. He is internationally recognized for his enormous, diverse contribution in statistical analysis of environmental data, fuzzy mathematics, evidence theory, artificial neural network, wavelets, and wavelet neural network. He is the recipient of Eminent Scientist Award, Millennium Flags of Honor from Indian Science Congress Association in the year 2010. He also has received meritorious awards from National Society of Radiation Physics. He has been honored as Professor in Physical and Mathematical Sciences in Homi Bhabha National Institute. He has more than 120 publications in peer-reviewed international journals, book chapters, international and national conferences to his credit. He is author of more than 20 application software. He is also a recognized PhD guide in engineering and science discipline. His research interest includes mathematical modeling, statistical analysis of big data, data mining, optimization using evolutionary algorithms, artificial intelligence, bioinformatics, sensitivity and uncertainty modeling. He is the reviewer and editorial board member of many international and national journals. He is the life member of many international and national scientific organizations. I welcome you, sir, to our AREC campus. Thank you.
Thank you, sir. Now I request Dr. S.B. Nimse, Director General PREC Rumi, to felicitate Dr. D. Ratna. Thank you, sir.
Our second guest is Dr. Shraddha Ingre, who is professor in the Department of Mathematics in New Art Science Commerce College, Ahmedabad. Welcome you, madam.
Now I request Dr. Pravara Rao, Director R&D, PRES Rumi, to felicitate Dr. Shraddha Ingre, ma'am. Thank you, ma'am.
Our third guest is Mr. Argya Chakraj, who is a scientist in Baba Atomic Research Center, Mumbai. Welcome you, sir.
Now I request to Mr. Bharat Bhogre Patil, Joint Secretary PRES, to felicitate Mr. Arjay Chattara.
Our fourth guest is Mr. Sandeepan Gwan, who is also a scientist in Baba Atomic Research Center, Mumbai. Welcome you, sir.
Now I request to SM Prograde, HOD Computer Department, to felicitate Sandeepan John.
Our fifth guest, Mr. Tushar Kantipal, is also a scientist at Baba Atomic Research Center, Mumbai. I again welcome you, sir.
Now I request to Mr. Pardane sir, Principal Polytechnic Glory, to felicitate Mr. Tushar Kantipal. Sir. Now I request to Principal Wire Sunday to felicitate Bharat Bhogre sir. Now I request to Principal sir to felicitate Dr. Nimse sir. Now I request to Principal sir to felicitate Dr. Priya Raman. Thank you all respected dignitaries. Now I request Dr. S.B. Nimse, Director General, PRES Rumi, to say a few words on today's topic.
Professor Vidya, senior scientist from BRC Mumbai, and who is the chief guest for today's workshop on artificial intelligence and machine learning. His team of three people, including scientists from BRC Mumbai, principal of this college, Bharat Bogre, other deans on the dais, of the dais, and dear students. Professor D. Datta is known to me from more than a decade. Actually, it happened that my first student, Professor Daimle, okay, she got some big major project from BRC, and she worked with Professor D. Datta, and they have some uh, group work in BRC. So one day he called me that can you arrange some course at Loni on artificial intelligence machine learning? I immediately say yes, but we'll have some workshop first, and after that we'll understand what kind of course we can design and what will be the methodology of implementing that course. Because I realize, and everybody realize now in India, engineering education only churning out graduates will not suffice the purpose, because you heard 3 days back, from coming June, 300 engineering colleges are going to shut down. Okay, and students are not that nicely paid. On the contrary, they are searching for a job after graduation. And one of the reasons, there are many reasons. One of the reasons is that apart from the university curriculum, they are not exposed to a technology need of the market. And they have to do the course after graduation. But here, a place like Luni, we have enough comfort here. You can design some courses dedicated for third or fourth years of degree program, so that when they are completing their graduation, they can acquire some enhanced skills in engineering. And you know, artificial intelligence and machine learning is one of the area which is in demand in the job market. And we thought that this is a good area, where this is the first program in this direction. We'll go ahead, and after some time we'll design some course with a minimum fees. We'll make this course available to the students of this campus, and if possible, some courses may be from outside agency, and stamping from that agency some brand name. Some courses, if you won't get a brand name, you can have use our own brand name and give certificate from the colleges. But bottom line is that they must get a hands-on experience on new technology, okay, related to their own domain knowledge, so that they are better placed as compared to other graduates from other engineering colleges when they compete for job in very competitive job market. This is the background of starting this kind of activity, and this will increase this activity day by day, so that we have n number of such activities, courses on this campus, and students will get benefited. They are not to learn for big cities, spending a lot of money, okay, after graduation, and then after they are getting job. We'll equip them for necessary skills when they are doing their graduation. About artificial intelligence and machine learning, I think that most of you in the audience is well familiar than me. Okay, we are old generation people. We heard about robotics and everything, and many times we were informed that robots do a better job than human being. When there is a zero tolerance level for human error, people prefer robots because they don't have the error at all. So this kind of we done some operations, medical operations are also done with the help of robots. I've seen the robots in the city in some engineering colleges also. So there is a importance of this topic is beyond doubt, everybody understand. And this topic, I am interactive with this topic because of my background as a mathematician. I remember in '96, when I was in Berkeley University, I purchased one book reasoning about uncertainty. And that talk about like from the probability theory, okay, then evidence theory, and then little on fuzzy set theory, the fuzzy logic, then nowadays there are rough set theory, there are so many things nowadays. Now these things about, okay, and this ultimately led to neural networking and artificial intelligence. Neural networking will make a mathematical model how the brain works, okay, with insufficient and imprecise knowledge, okay, and still our brain take a correct decisions. This is experience of everybody, human being. All the time, every minute we take some decision. All the time we don't have the 100% information. We have the incomplete information that are also imprecise. It may not be foolproof information done by the Supreme Court. Okay, we have the imprecise information, incomplete information, but still our brain, with the experience, take a correct decision. And same principle is exploited by modeling the neural network theory, and that is also within artificial intelligence. That way I am going with this area. And the last comment, all of us know that for last 70, 80 years on the planet Earth, there is a total change in technology. What we know in 100 years back, 50 years back, now 10 years back, is totally changing. We experience in day-to-day life. Okay? And the starting point is, the first milestone is, starting with the Shockley's work about transistors in Stanford University, for which he got a Nobel Prize. First, he developed these transistors, the revolutionized the electronics, the revolutionized the industry, it becomes this fruits and flowers valley become a Silicon Valley, and whole America changed, and whole Europe changed, and then the whole lifestyle of everybody changed. Okay, so there are certain milestones in the development of this computer science theory. Shockley's work is one of them, for which he gets Nobel Prize. And there are so many other stories also. But I think that apart from its historical aspect, youngsters must know what is the present status of these developments. And they must know from the horse's mouth, meaning thereby those who are really doing such kind of things in their professional life. Because we as people, there won't be any compromise about the quality and preciseness, because they are dealing with the one of the premier institute of India. Okay, so we will design the courses with help of these people. We'll have more set of people in afterwards. And this is our program. And I hope that if we do for 2-3 years continuously, we can develop our own model how to supplement our university curriculum to such kind of skill-based, knowledge-based activity, and this is one of the activity. So with this work, I welcome Professor Dr. to this campus. We can talk more about the society and all these things. And since we are behind schedule, I will not kill more time, but I will say one way. This is a society, the wishes of Padmashri, Vikhe Patil, then his son Balasav Vikhe Patil. They developed wonders in this area. In a small village of 6,000 to 7,000 population, it became about 70,000 with students, and all kind of education is possible in a small village. Okay, this is happened because of visionary leadership and support from the local people. Okay, now it's our moral responsibility to provide the quality education to all these people and enhance the standard of this institution at least at the national level. And this is our efforts. Again, I welcome all the scientists here and best wishes for this activity. Thank you.
Thank you, sir, for your motivational speech to the participants. Without any further delay, I request Dr. Vithalrao to start the today's session.
So very good afternoon to all of you. I am really honored here to see that this August gathering, and I hope that whatever today I am going to describe, it will cut into this particular institute in a different domain. But before startup, at the outset, I would really like to express my sincere gratitude to Professor Nimsesal who had already expressed that we have known each other for a decade and worked with a good project with a new theory known as the evidence theory with Dr. Swadhyayinde. And from there only, it came to my mind. In fact, when I joined into BRC, when I shifted from physics domain to computer science domain, that was my first dream that when human intelligence can bring into the market to produce some societal benefit oriented task. But that time, if I really uh, stepped in, it was not possible for me to explore. So it is better to, when you study a big chapter, we should divide that whole thing into the paragraphs. So I did the same thing. The complete chapter I divided into paragraphs, and each and every paragraph has got some connectivity. Maybe that connectivity I will explain by the neural network, which does not have any functional relationship, but it has got the relationship. So that way we step in. So today's particular topic will be mostly based on the artificial intelligence. Okay. Now, uh, we would like to first define that what is the working definition of AI. I could have given only the definition of AI because if you follow the literature, then you will see that the many literature has got the many different definitions of AI. But then ultimately when you work with the practice, that definition should be molded into such a way so that you can devise something. So from that respect, we call it as a that artificial intelligence. What is the working definition? So working definition is saying that it is nothing but a study of how to make the computers to do things similar to the human behavior. That means human intelligence we are trying to bring back into a machine, and that is why it is called the artificial intelligence. So this is basically a program. Many of the things people may say that it must be a computer, but early days that concept was there. But nowadays concept has changed into that. It is basically programs or you can say the collection of programs which we call as a software. So these programs or software are better if they could extend what they do a worldwide website amount of data. And then this program should be such a way written or developed, it should not make any mistakes. That means it has got the intelligence. Okay. Now, question is again the why AI? So, main reason is that it has the two purposes. One purpose is that we can develop we can think about the power of computers to augment the human thinking, just as we use the motors to augment the human or horsepower. For example, as already Professor Nimshes have mentioned, that in the early days only the robotics was the main fact. So robotics, and then as a computer program, the software we call as the expert system. So they are the major branches of that particular area. But other is to use a computer's artificial intelligence. That means computer should have intelligence. In that way, that it should understand how humans think. Okay. Now you will see slowly, basically when we try to give a thing that we already know that from the architecture of the computer, CPU is the brain of the computer. That means computer has got a brain. So therefore, we can develop some kind of intelligence. When we do the intelligence, definitely we should have a memory, right? So therefore, we have to think about the memory. And when we go for the, of course, slowly, I will come into that context. When you come back to the memory, then you will see it is basically a cognitive science. And evolution of cognitive science is from a branch which is no way connected with the science domain. It is a psychology. So therefore, it gives us the first flavor that a psychology people can develop only the artificial intelligence. And this artificial intelligence subject is a computer science subject. Then how it can be framed? Psychology is one domain, computer science. So that means there must be some relationship. That relationship we will try to achieve by the system which we call as a neural network. So that means two different domains which does not have any functional relationship, but still we can have that. That is basically called as a neural network. We'll define one by one, and this kind of definition is given by the Hart Simon. That's his name I put there. Now the first is that what is the concept? Now when you start with a artificial intelligence, of course people should understand that when you try to develop the intelligence, a large amount of mathematics is involved. But if I show that the mathematics first, then many of the people, I think those are the backbencher will be just start sleeping because it's the afternoon. So therefore, I thought that let us start with the understanding first. What is the concept? Now, the concept when you try to understand, I took an example of this chair. Okay, so one after another slide, I will show that there is all sorts of chairs. And from there, automatically it will come to your mind that what I'm going to speak in the next few hours. Okay. So now see, this is a chair. Okay. It has got a very good frame and all these things. We can very well understand that it can see. If I change that again, this is also a chair. Okay. But definitely not before that sentence. This is slightly different. This is also a chair. Again, you see this is also a chair. You see that this is also a chair. Okay. So then again, this is also a chair. Okay. Again, you see this is also a chair. Now, see this is also a chair. So many chairs when you have seen, this is also a chair. Okay. Now you see this is also a chair. So therefore, now this is again chair. That's why I brought this concept. Then this is also a chair. Because each and every systems we have seen that whatever so far we can see. Then this is chair. This is also chair. Okay. Now you see this is also chair. So therefore, the question is that when you go for that, so earlier that when you try to do that, so question is that so many chairs of different shape, different pattern we have seen. Can we give this thing to the computer? So that means I am teaching computer, writing a program by giving the image of this chair in the computer that you identify which is not chair. So if I can teach the computer or if I can write the program, put it in the computer, when we run, if we show that the image, then computer has got a learning ability. First one or two he will learn. You will see that it has got 4 legs and it has got a very good square platform having a back seated. So definitely you will identify by that minimum things that it is. Right? Same way, if you show some red colored ball or green colored ball to a just a grown child, and if you give some other color, he will not be able to identify which is the color, but he will definitely identify this is a ball because the shape is. So therefore, depending on the geometry of the object, we can identify. Okay. Similar to that, depending on the functional relationship also, we can identify the system. When we talk about the functional relationship and the geometry pattern and all these things, it gives me a flavor of that, not only to me, for everybody, that it is a pattern recognition. So pattern recognition is one of the brands in the artificial intelligence. Okay, that's the point only I wanted to say. So therefore, a quote from John McAfee, he mentioned that in order for a program to be capable of learning something, it must first be capable of being told. Okay. So therefore, if you can tell before you learn, so you must be heard. So these are giving the message that we have to just communicate properly, and then the communication, if it is perfect, system will learn. Why we cannot learn? Because our communication is very poor. That's the thing. For example, that if a teacher teaches his class, if his lecture or her lecture is not interesting, that means that the communication is not going to the last bench without the microphone. So therefore, definitely last bencher will not understand. So he cannot teach. He has not learned. So the learning ability is nothing but the improvement of the teaching process. That's the basic one. Okay. So therefore, we have to do that. So the question is that do we believe this? Let us see. Again, that Dartmouth conference was the first conference where artificial intelligence coined, and these 3 guys in 1955, August 31st, they mentioned that they proposed that a 2-month, 10-man study of artificial intelligence be carried out during the summer of 1956 at Dartmouth College in Hanover, New Hampshire. The study is to proceed on the basis of a conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. So it is a very old story. Now so many changes have occurred. So there is a timeline, the picture, 1956, the conference announced, 1981, subsequent to that, Japanese fifth generation project launched as the expert systems, age blueprints in the US, then 1988, AI revenues peaked at $1 billion, AI being just beginning. And one of my dream was that when I studied the computer science at the first stage, then I found that every intelligence developed by from the point of the nuclear war. Any kind of intelligence developed from the point of nuclear war. Since we are handling the nuclear weapon in my institute, so I found that time, and very early stage I involved in the nuclear weapon design. So then I found that the AI domain maybe the actual is the our domain. So I proposed that I would like to do the work on the AI domain. That time it was the expert system, rule-based expert system and expert knowledge-based expert system. So I tried to develop the knowledge-based expert system and then develop so many, which I cannot say in detail. Some weaponry design we did that. And almost I am familiar with the many places at all the defense areas, including the Air Force, Army, and all other nuclear submarine also. So therefore, the origins of the AI hype, 1950, if you see that Turing predicted that, Turing machine you know is a very famous machine. So Turing predicted that in about 50 years, an average interrogator will not have more than a 70% chance of making the right identification after 5 minutes of question. 1957, this guy is very famous, Newell and Simon. They have a very well book on the artificial intelligence. Predicted that within 10 years, a computer will be the world chess champion unless the rules bar it from the computer. And you must be remembering that in the 1980s, a lot of computer games started coming, like Prince, Vikhe, game, lot of games came. All the games have artificial intelligence. So people enjoy the AI first, seeing that it is giving as a product of the various games. And those games finally come back to our mobile. And that's the mobile computing started. That's the basic origin. So evolution of the main ideas you see, rings or not, the games, mathematics and other knowledge core tasks, silver bullet, knowledge-based systems, encoded knowledge versus machine learning, low level, maybe the sensory and motor processing, and the regular resurgence of symbolic systems, robotics, and then finally natural language processing. Okay. The most hurdle was how do I code it? So the natural language got developed. Okay. So therefore, before that natural language, we have to do the symbolic math computation. So therefore, symbolic versus sub-symbolic. So each and every domain is giving a course also for the artificial intelligence. That means in the artificial intelligence course, we should have at least 5 to 6 lectures on symbolic math computation. This is a very good domain, and you all know that based on the symbolic math computation, a very good software has been developed. Which is that name? What is the name of that software? Mathematica. Mathematica is based on symbolic math computation. Total. So therefore, symbolic AI, sub-symbolic AI, model intelligence at a level similar to the neurons. Let us think about some knowledge and planning emerge. So the symbolic AI, that means we have a model. It has got some kind of embedded knowledge in the pneumatic code. For example, the one I have given the blueberry, whether it is asking is a fruit, the shape is round, color is purple, and size is 0.4 inch. Okay. So even if you maintain all the attributes, but that fruit may not be a blueberry, but computer will understand this is a blueberry because it's matching with the all that. So that is called as a symbolic computation. That means in the symbolic computation, we can simply translate our natural language into a mathematical domain. Okay. For example, to some extent, symbolic computation is there embedded in the MATLAB, where we have a symbolic math computation toolbox. You are writing a function, say e to the power minus lambda t, where lambda is given. I would like to know that what is the Laplace transformation of this e to the power minus lambda t. I know that the Laplace transformation of that everybody knows 0 to infinity e to the power minus st multiplied by e to the power minus lambda t and dt. So it will transform into the S domain. So in the MATLAB, if I write the Laplace and that function, it will give me the result. So the Laplace is the word which is programmed by using the symbolic math computation. So this is the symbolic math. Not only that, we can do very well partial differential equation also. If you write the del square, that psi plus v psi equal to 0, this sentence, if the initial condition like IC or BC as the boundary condition, it will give me the wave function. And if I plot the EZ plot, it will give me the plot. This is a symbolic math computation. So, but I have seen very much rare that the symbolic math computation teaches in the mathematics. Never. It should be. So this is one area in the artificial intelligence domain. Then again, now you see the origin of the sub-symbolic AI. Very old 1943 Maxlow and Pitts, they developed the logical calculus of the ideas immanent in the nervous activity. So many functions or inputs you are given and you are getting the outputs. So all this, our brain, the way it is working is nothing but the neurons. So all the neurons is giving their activity and giving a proportional logic, propositional logic, and then give the output. That was the basic initial domain of the sub-symbolic AI. So there is a gains as we told. Then we try to prove a lot of theorems, theorem proving. So when we try to prove the theorem proving technique gives a language called as a prologue, programming in logic. Early days, we started learning AI by using prologue. Prologue gives us, if I write as a child A comma B, that means A is the parent, it has got a child B, right? So if I write that the child Tom and Joy, that means Tom has got a child named as Joy. Okay. If I write that Mary likes badminton, John likes badminton, and if I keep the Mary comma John, that means it will like whether brother Mary comma John, sister Mary comma John, computer will identify whether they are brother or sister. So like this only, that lot of programming logic came. That is called prologue. And when you go for the prologue, then predicate logic and subjective logic came. Okay. So therefore, it gives an evolution like 1950. Claude Shannon published a paper describing how a computer could play the chess. You may be remembering that the chess game came out. That is also artificial intelligence. 1952-62, Art Samuel built the first checkers program. 67, as I mentioned, Newell and Simon predicted that a computer will beat a human at chess within 10 years. 1967, MathHack was good enough to achieve a Class C rating in tournament chess. 1994, Chinese became the world checkers champion. Then 97, Deep Blue beat Kasparov, and 2007, checkers is solved. Many more things are there. I have not listed. Every year, some kind of, and many of the time you must be knowing that this artificial intelligence development flavor was earlier also there. It gave me a theory that is very famous, game theory. But the game theory, economics people only apply. Science people hardly I found they apply. But if they apply, a lot of optimization they can do. It's basically search. Okay. Those who are the electronics engineers, they must have heard the knapsack problem. Right? So knapsack problem is a search basically. Okay. And then you can apply the game theory to have a complicated circuit, like complete board itself, by applying the knapsack technique, by using the AI. So these are the areas where we can give the flavor to the student how to teach those things. So as I mentioned mentioned that logic theory came. It is divided at the 1956 Summer Dartmouth conference, which I mentioned that probably the first implemented AI program. And logic theory did what mathematicians do. That means they started prove the theorems. All sorts of theorems try to prove. Pythagoras theorem first proved by the artificial intelligence. And there is a theorem called Bacon's theorem. Bacon's theorem we apply for proving that the Boyle's law and Charles law. And when we try to prove that the Bacon's theorem in the same year, that is 1957, we understand that what is Charles law and what is Boyle's law. So it's a very important Bacon's theorem. Lot many things I will show you that. And surprising thing that if you study that, because I have studied the Principia Mathematica in full, and then I found many of the time Newton's also has flavored at that time only artificial intelligence. But our understanding ability was poor, so we cannot convert his language into the problem solving domain. In the Principia Mathematica, maximum problems are already given here. Only thing we have to read and understand. For example, everybody reads Gita, but how many of them are really understanding what is the meaning of that? We never understand. Okay. And if we understand, then we can enjoy the Gita, then we will read the further chapter. Since we do not understand, we just keep the close and many of the times our normal book also saying. If you do not understand, that subject will be getting the fail marks. Out of 100, I will get only the K and not 9 because we never understand. So therefore, understanding, memory, learning ability, all these points are given in the Principia of Mathematics. Again, if you see that the logic theories use the three rules of inference. One is the substitution. Okay. So now you see the example from A that and B, which gives the A. That means it is if it is a fuzzy rule, or if it is giving the A as a fuzzy and Q, B as a Q, then it will give me a conclusion that okay, yes is the fuzzy. So that means some kind of conjecture mapping it is giving. Similarly for replacement from A to B, it concludes that there is not A or B, so it gives us detachment. So that means logic theories, people used to have some kind of rules of inference like substitution, replacement, detachment, like that only they were building the AI program. Okay, all these things used to have the programs. Okay, and at the same time, when computer engineer came into the market, they told that this program is not giving me that drawing. How do I go for the drawing? So for the drawing, artificial intelligence based drawing came by language called list processing. List. Okay, if I do the list, definitely your complete drawing will come out. And at the different layer, it will also give the estimation. Throughout my career, I have trained the two Shardarji for the list program. And they were from the different countries. They were sometimes that time I was at Kalapur power station. So they came to the context of some engineering, some nuclear domain. So I was involved in that project. So I trained them the list processing, how to do the costing as well as drawing. So that was one of the flavor of my artificial intelligence. So again, you see that the inference tools that LTUs are not complete. Proofs is produced are trivial by modern standards. If you look at the example, you have given the axioms and the theorems prior to it. So LT logic theory people tried for reference 15 minutes, but failed to prove the theorem. So that means some kind of hurdles is there. Significance lies in the fact that it opened the door to the development of a more powerful system. When they try to fail, so something may be missing. So that was the basic idea. So ultimately, it came back to some kind of mathematics is required. So 1956, logic theory is developed as the first running AI program. 1961, science solved the calculus problems at the college freshman level. 1967, maxima came, and gradually theorem proving has become well enough understood that is usually no longer considered as AI. Okay. So that means we have to discover. We have discovered. What discovered? We discovered the Goldbach conjecture. This is one of the conjecture where multi-logics will be connected. Okay. And then prime factorization theorem, because when you try to run the computer program, so teacher always gives the write down a computer program for prime number 1 to 10. The next course is that they write down the computer program for Fibonacci numbers. And the next course is that the Fibonacci numbers programs used for researching. And you will really find it out that the 500C programs today, biology people try to connect to understand the reproduction facility of the tortoise and rabbit. So they try to find the genomics and proteomics. That's the basic origin. So that system goes from there to there. Okay. So then, what about things that people do easily? Common sense reasoning, vision, moving around, and then finally language. So these are the generally people understand. So therefore, continuing into that, I guess that if you have a problem, think of a first situation where you solve a similar problem. If you take an action, anticipate what might happen next. That's the basic idea. If you fail at something, imagine that how you might have done things differently. If you observe an event, try to infer what prior event might have caused it. If you see an object, wonder if anyone owns it. Okay. So, for example, suppose you have seen the object which you have never seen. For example, maximum time we have never seen that the lower part of the object has got a fish and the upper part of the object has got a beautiful woman. Okay, so we have never seen. Similarly, for the seahorse. So if you see that object, then you will go on seeing that you will understand how it came, where from it came. So when you study, go on, your learning ability increases, imaging increases. So that means you see an object, wonder if anyone owns it. If someone has done something, ask yourself what person's purpose. What is the purpose of doing that? So ultimately, people will say that they require some knowledge. Why do you need it? Find me stuff about dogs who have people's life, who save the people's life. Then the question is that how can we present it and use it? How can we acquire it? So when these questions came to the mind, then we try to understand, we try to put the drawing, and from the drawing we try to develop a implementation of the mathematics with the algorithm. Algorithm ultimately gives you the program coding. You code the program in any language, feed into the computer together. That's the basic way of AI-based program. So here also you see that two people spot a fire, they are backing alert neighbors to call 911. For example, there is a very common problem which I solved at the very early stage. Neighbor has got a one dog. Dog has got a habit of that particular dog has barking at the night. Okay, sometimes early in the morning. And that area where that fellow stays, outside there is a jungle where one donkey also was there. Donkey also barks, that dog also barks. How do you identify that who is barking, dog or donkey? Assuming that both the pitch of the barking are same. Either you have to open your door and look at your veranda that whether it is a dog or not, or you have to open your room where you are keeping the dog with a bed. So that means they will ask you to come up, get up from your normal position. So this gives the idea that you are bound to increase your knowledge. That is it. So therefore, these two examples is giving the knowledge discovery. That is it. Okay. How to discover the knowledge. So we divide the things into concepts. What is a party, what is a kite, and what a piggy bank. So these are kind of questions. Initial stage, any AI teacher will teach like this on the questions and try to answer. So some things are easy. If dogs are mammals and mammals are animals, are dogs mammals? This is a question. And there are a lot of puzzle questions you can build in there. And more you solve the puzzle questions, or what we call the googly, you will able to increase your knowledge. Some things are harder. If most Canadians have brown eyes and most brown-eyed people have good eyesight, then do most Canadians have good eyesight? So that means you are correlating. So your matching is there. Okay. Maybe may not for at least two reasons. It might be true that while most brown-eyed people have good eyesight, that is not the true of the Canadians. Suppose, just as an example, 70% of the Canadians have brown eyes and 70% of the brown-eyed people have a good eyesight. Then, assuming that brown-eyed Canadians have the same probability as other brown-eyed people having good eyesight, only 49% of Canadians are brown-eyed people with good eyesight. So this is a kind of phrasing. Same way, now you have to go for the concept acquisition. This was our the knowledge discovery by framing the lot of phrases. Now, if we look at some geometrical object, that is concept acquisition, how we can acquire our concept. Okay. The acquisition program learn the concepts in the blocks of the micro world. There are many kinds of blocks you are seeing: arch, near miss, arch. So from that we wanted to see that what kind of object it is. Okay. So therefore, from the arch is the top portion is there. Maybe that is side wise we will see side two, and then we will try to find it out. Okay, this is the object. For example, if I try to show you some of the spherical object and ask you that is it a sphere? Okay. So if I show you that, you will say no, it is not a sphere because it is a cross section only you are this. Cross section of the sphere is nothing but a circle. Okay. So the fellow who is seeing from that side, he will not see that the cross section is a proper way. He will give that it's a triangle. Okay. So that means the same object, just at the one point of instance, if I look at from the different angle, it has got different meaning. And similar kind of thing only we do in the humans only. Because when our ministry level people look at if people at a different angle, so the closeness increases. Okay. So that was the basic way of doing that. So the reasoning is that we can describe the reasoning as search in a space of possible situations. Okay. Many of the time you may knowing that when we try to put our device into the proper domain, we have to take a lot of reasoning, lot of discussions. And when many people discussions come to the same umbrella, then only we take the decision. So ultimately, it is a decision making. Why AI is important today? Because we have to take the decisions. So decision making may not be possible in all the certain conditions. Okay, because many of the time conditions are not certain. For example, this area is very good area, and we do not know that December month Mumbai there will be rain. We do not know. So therefore, all umbrella shops are closed. And suppose you do not have any umbrella, what you will do? You will not have any umbrella. Umbrella shops are closed. Nobody is having the stock of umbrella. Nobody is having the rain. If it works for it, if the rain continues for a month, then you will have a lot of time. And from that, one particular domain of the people will gain because of the they will satisfy you by giving the umbrella and raincoat and rain shoes, and then you will satisfy him whatever the amount he requires. So one part will be domain high, and you will be the. So therefore, ultimately, idea is decision making under uncertain environment. So AI-based technique is the decision making under uncertain environment. So even if we do not find the artificial intelligence, but we will find the decision making under uncertain environment. And when we go for that, we will have a definite paradigm shift that either be probabilistic or epistemic. Okay, that means I do not know, that is imprecise. That part we drag it as a fuzzy mathematics, where we do not know imprecise, and probabilistic we do by the experiment. So therefore, you will see that after some time that there are two kinds of people in the AI community. One believe on the data, another believe on the oh, your data is not, you are biased on the data generation, so I do not believe the data. They want that is some opinion, which we call later on the expert's opinion, and which we worked out with the Dr. Sudhan as an evidence theory. We will show you that all these are one branch of the artificial intelligence. So therefore, our idea is that when you try to do that, one kind of people are the probabilistic, they are the frequentists, because probability domain is based on the frequency of the repetition of the number of experiments. Whereas the other part of the domain is the epistemic, they are the subjective people. Okay. Now, how do we interface? Interface is possible by the a very important learning technique called as a Bayesian learning. Bayesian learning, Bayes theory. Okay, we will show that. I have brought the examples, very practical examples. So now you see that there is a breadth first start. We are trying to do that. There is a lot of in computer domain. If we go for the data structure, we have a linked list, linear linked list. Okay, doubly linked list. Then we have a circular. Then we have a lot of tree traversal, and one of the tree traversal technique is the search. And from the search, this is the breadth first search, and this is the depth first search. how the searching can be done, and you see that when you try to do the search problem, it is a bottom-up approach. Bottom-up approach means first incident has happened in the bottom line, and you are trying to find out what is the root cause. So this particular search is giving the root cause analysis. So if any kind of system fails, you do not know what for it fails. Your result is that it has failed. So you are trying to put that in logic and logic and logic, and then you are trying to put that theorem that yes, because of this reason it has failed. So that means you are trying to solve the logic from the bottom. When the bottom, our result is a goal. So the AI-based programs are basically the goal-oriented program. When you try to develop a program, we have to approach the bottom up, not top down. Normal program, classical program, which is called as a procedural program, it is a top down. From the top, it analyzes. From the AI-based programs, it's the bottom up. It's a goal-driven program. So in a single sentence, that what kind of AI programs are? AI programs are basically bottom-up program, and it is nothing but a goal-driven program. Okay. So we try to bring another example, British Museum algorithm. It's a very famous algorithm, a simple algorithm, generate and test. When done systematically, it is basic depth first. But suppose that each time we end a path and we start over at the top and choose the next path randomly. If we try this long enough, we may eventually hit a solution. We will call this as the British Museum algorithm. Why that name given? Because if you try to go into this particular museum, it is connected in such a way so that in many of the museums same thing happens. If you go into one room, though we have decided I will cover this part, but the rooms have been connected, so we will very much. Okay. So then another algorithm gives us the monkeys and typewriters. You must not have seen that how monkey types a typewriter. If you really see that how you train him, and you will see that hard typing script and human time script are the same. You will surprise that. That means, though I have trained that in a different way, but he has got the intelligence. He will apply that intelligence, and later on he will find it out that we were earlier days monkeys. So this is the intelligence. And that's why it was the monkeys and typewriters algorithm. Is a website I have given. If you look at the website, you will see that plenty of examples are given. So ultimately, the problem reduction is a goal. What is my goal? Is to acquire a TV. Now to acquire the TV, I can steal the TV. I can earn money and then purchase, or I can buy the TV. So like that, I can do many things. My goal is that I acquire the TV. So which is correct and which is not correct, that we will decide by the knowledge. Okay. So or another one, theorem proving, in which the reasoning backwards from the theorem we are trying to prove. So then with that, now I mentioned that how we can show that artificial intelligence. First few of the slides gives you the flavor that is a basically a computer program. It requires a knowledge discovery. We try to embed ourselves how to learn the system. Okay, learning by seeing the objects, learning by fact finding, and if you try to learn, many of the time we used to call it fact finding by interview. You do not know, but if you interview many of the people, you can find it. Okay. And one of the technique we have application is the Bayesian learning. If you look at this figure, that I have just given an example. Suppose there are 5 kinds of bags of candies, 10% are each one. Is to 100% cherry candies, 20% are H2, 75% cherry candies plus 25% lime candies, and so on. And then we observe that the candy is drawn from some bag, and then you have to identify what kind of bag it is. So that is a knowledge discovery. So the example because of this nothing but what kind of bag it is and what flavor will the next candy be. So such kind of thing, if you do that in probability theory, you will not do it. We have to apply a probability theory called condition. So that is why conditional probability theory is nothing but the Bayes theorem. So the Bayes theorem is that the probability of occurrence of hypothesis A, condition that the data is given by the D, is nothing but this formulation. Okay. So probability of occurrence of the data, condition and hypothesis given, and P of H is the probability of occurrence of hypothesis divided by the denominator is the probability of occurrence of P. I have already mentioned. And now if you look at in another domain, now if I do this thing, people will beat me. You are doing the artificial intelligence, bringing back again to mathematics or something. So we will not understand that. Then I have to translate their language. How to translate their language? But computer people understand. So therefore, I will mention that the P of D by A as a likelihood and remaining things as a prior. Assuming that the P of D is a non-knowledge. Non-knowledge probability is 1. So I forget about that. So therefore, any conditional probability or called as a posterior probability will be mapped into the product of the likelihood into the prior probability. Okay. Prior probability I may be assuming and the likelihood I may be enumerating from the data itself by putting so many processes. So therefore, it is a full Bayesian learning where we use the learning as a Bayesian updating of a probability distribution. As I mentioned, that H is the hypothesis variable, so many values are there. So where the prior probability and then remaining condition as a your likelihood. So P of D of H by is called as a likelihood. Likelihood means that you are just doubting that this may be the possibility. Then second time you are updating. That is the way actually you are doing. Okay. And if you do that, what basically you will do, the left hand side, what I told you that the probability of H condition that the D given is called as a posterior probability. And the posterior probability hypothesis is showing that the graph that if I increase my samples, then after some time that posterior probability will be convert and that will be my ultimately posterior probability. Okay. And many of the time, this is a very, very important concept that we apply very often to understand that, because one of my colleagues, he does the neutron spectrum. Neutron spectrum is nothing but I have a radionuclide which will give me the neutrons, and neutrons are basically a huge range of energy, and to catch all the energies is not possible. Okay, so what we do, we put some of the detectors. So all the detectors are not possible. So therefore, with the help of the few detectors, when the spectrum recorded, we try to understand what are those energies where the detectors have not been placed. So we try to find it out, that hidden information. So this kind of hidden information is known as the unfolding. So unfolding is done by the Bayesian learning. So if you can develop a system by inputting the Bayesian learning for a neutron spectrum, it will give me the unfolding. And if you really look at the unfolding software which are commercially available, is not available in our country so far. It is all available from the US, and one software costs almost more than 70-80 lakhs. So where our digital India concept comes, if we spend the 70-80 lakh to purchase a unfolding software, that too also one license, how do I satisfy my Prime Minister concept that India should become a digital India? We should develop the technique of the AI, so that we can say that the people look that we also have developed our unfolding of the neutron spectrum. Similarly, another one of my colleagues is doing the medical physics imaging, medical imaging. As you know, medical imaging is a very, very important concept. So how, and there also we have a software called treatment planning software. TPS software is not available in our country. Now we are trying, it is not available. And this cost around more than crore. Not only single crore, more than crore. Because if you look at the variant machine in the LINAC, which is housed in many of the hospitals, a variant machine itself is probably more than 20 crores. And out of the 20 crores, that almost more than 50% is the software itself. So, can we not apply our all brain together, all over the state to develop a treatment planning software? If we can, that is my view. We can, because nothing is there. And if we do that, a lot of patients will be saved their life. Because when you purchase a black box, we cannot do anything. If anything wrong happens, we call the engineer, we pay the engineer, whatever he will do, we will never understand. So this is the way that our money goes to this point. Okay. But if we can develop ourselves, we can sell our treatment planning software to the foreign countries or to neighboring countries like Bangladesh or some other Asian countries. So this is very, very important that the machine learning from the point of the to make clearly that our TM score, that is digital. So therefore, one of the attributes is the math. Maximum likelihood method I will describe, but math is nothing but the maximum a posteriori estimation. What it does, we describe the posterior probability, and in that likelihood is there. Likelihood is nothing but the probability, which is done by the maximum likelihood principle. Their own parameter we estimate. How do I satisfy that the parameter in such a way, and how to know that that parameter is optimal? So we have to bring that the optimization concept. And when you bring that the optimization concept, it will give you that the area of the operation. So therefore, why I choose now, you can easily say that by using the machine learning, we can cover many of the subjects in the mathematical domain like operation research, then many of the game theory, a lot of economics comes into picture. So one by one. Okay. So this is an ML approximation for the large data set, maximum likelihood that is ML, learning, choose the HML, means maximizing the probability of DA. So it is simply get the best fit to the data, identical to map for the uniform prior, and ML is the standard, which is a non-biased. So in the Bayesian, you have a probabilistic, which is done by the maximum. And then maximum likelihood parameter learning in the bias nets. So you can see that the mathematics, now details are not going. It is nothing but you have a data. That data you have to fit to a probability distribution. How to fit that? Maximum likelihood principle. Okay. When I do the maximum likelihood principle, if I multiply by the prior, if I know, nobody knows the prior, so everybody assumes that the uniform, and then multiply, get the posterior probability. Next time this posterior probability will become the prior, and that will continue. And at the point of time, you will convert, and that is your posterior probability. That means you have already determined these occurrence is due to this particular condition. Okay. So therefore, this is first flavored to in the CBI domain. That dacoity has occurred, the huge dacoit, lot of murder case was there. What was the reason? Police people applied the conditional probability to identify who is the criminal. Advocate people raised the question to the judge that this is the condition. So conditional probability is there. And when we do that, depending on the conditional probability, in the practical domain, we develop the conditional probability table. Right? When we try to develop the conditional probability table, and you will see that the connectivity means I could connect by that way. It is nothing but the graph theory. Then computer domain that the graph theory came into the picture. And it was enjoyable to me that they are a graph theory. If I can apply this way, then nobody knows that the graph theory. Let us teach the graph theory how to apply it. Our Bayesian. I will show you this is called the Bayesian next. That's why we got it. Bayesian. So most probable classification of the new instances. So far we have sorted the most probable hypothesis given the data B, that is called H map. Given the new instance X, what is this most probable classification? Consider that three possible hypotheses, that is P of H1 by D is at 0.4, H2 by D is 0.3, H3 by D is 0.3. You have to read like this the probability occurrence of hypothesis 3 condition that the data is given. Now if you have given a new instance X, like H1X is positive, H2X is negative, H3X is negative. So question is that what is the most probable classification of X? We apply the bias optimal classification of the H map. So this is my formulation, and we'll see that all the examples are given. We classify the instant D as then. Finally, with respect to these assignments, that we assign the D as a number of samples in D if I give, and it will give, and ultimately it is touching the one of the 0.9 almost or 0.95. So that is my probability confidence it will give. So ultimately, we apply the bias as a classifier. It's called as a name-based classifier. Important special, simple of a bias optimal classifier. You have a hypothesis that is equal to classification. You have the class. You can give the attribute 1 with respect to that class, attribute 2, attribute 3, and then based on that, you can identify that class. When you do the class, then you give the neural network converted into another domain. It's called as a support vector machine, SVM. SVM is a classifier, and you will surprise that SVM classifier first time I could apply to a practical field. Functional. Padmashri is an area where there is a lot of agriculture industries there. They crop the mushrooms and seeds. So they called me for some kind of cutting edge of technology. When I described this SBL, then they took me to the field and told me that they can you classify with your software. I told yes, you can give the image. And then I gave the technique. And today also that applied. The idea was that by utilizing that program, they could bring the seeds like this much of land. It's a good product. So that was my basic aim of artificial intelligence. So it was really applicable and it was applying. Today, if you go to the many of the studies shop where the women go for the purchasing their good studies. So they apply the support vector machine to identify which one to be choose with the less amount of time. So that husband will not be disturbed that the wife is just purchasing studies. So that kind of technique we can apply the societal benefit. Anywhere it is available. So the naive bias classified is that most probable value of x, argument maximum. You see that I'm not going to the detail in the mathematics because that is again the different session. So this is the way that we try to go and then finding out the maximizing of that. So what is the learning to classify the text? Why? You learn which news articles are of interest. You learn to classify web pages by topic. Naive bias is among the most effective. So naive bias basically of the classification technique. It can learn the whole system. Learning to classify text, you have a concept of interesting. Learning is nothing but the training examples. You have to train the examples to give the positiveness, to give the negativeness, and you have the probability of document having the condition plus probability of occurrence of documents having the negative. Then it conditional impedance independent assumption is there. So this is the formulation basically we try to quote. Pi is the symbol for product that everybody knows. So we are not explaining that. So in that assumptions you have to see that each and every condition are independent. So having that independent, we can establish a joint probability where many of the things are already embedded. Okay. So you can learn that the naive bias text. These are the various examples. We can skip this slide because these are required a lot of examples too. So classify the naive bias as the text is the positions, return to the VNB, and in our domain we try to identify the nuclear reactions. Okay, we try to identify what kind of particle it is. Is it a positron? Is it an electron, a neutron, or many other harder particles like hadrons? Okay. And as you know that after some time you will have a proton therapy in our medical domain. Already Apollo Hospital has launched in the Mumbai, where I had been present during the inaugural session, and the chief guest was Monisha Paila, because she is having the breast cancer, so she came and she expressed that because of the proton therapy, she's looking for a better optimal surgery. And all these things is based on the AI technique. We can identify the image like anything. So this is an example. 20 news groups are there. So many computer graphics. You see, so many groups are there. Idea is that how many of them are the accurate? So 89% classification we can make at the different types of people, and that is the naive bias application. Okay. So if you really plot that the learning curve for the 20 new groups, you will see that for bias it is giving the maximum satisfaction compared to any other classification domain. So the learning the Bayesian networks, several variants of this learning task is there. Now when you learn that by using the Bayes theorem, that means I can develop a network. And if I do the network, it's called the Bayesian network. Okay. So the network structure might be known or unknown. Training examples might provide the values of all the network variables or just some. If the structure known and no missing values, it is as easy as training a naive bias classifier. This is generally when you write to program, we follow this kind of technique. Okay. Now, here, when we try to do, why does a mathematician always is important? I am not a mathematician, but I have converted mathematician. My professor used to tell that you are not the mathematician, you are converted. That means I have converted myself. So converted myself means I have learned something and then I may not be correct, maybe wrong somewhere. But here I found that expectation maximization. This is the first time I worked in my BRC, very first time. So far, no engineers have worked on that. When I tried to find it out, what problem was that many of our data was not recorded because of the instrument. And we used to call them as a below detection limit or below detection level. Since nothing is coming out, we are understanding that is my limitation capability of my instrument. Now the same sample, when I try to experiment in another laboratory where they have the more sophisticated, showing the counts, then how can I say that it is below detection level? That is my limitation of my laboratory. So then I challenge that. It may not be true. Below detection limit, even though it is there, I may not be knowing, but try to find it out by using the Bayes theorem. Can we know that what is the below detection? There it is. So then I was searching, then came up with this. Expectation maximization has been coined by three fellows. Two of them are physicists, and one of them is a psychologist. I read their bibliography, how they could achieve that. Then this expectation maximization came out, and one of them is nothing but our evidence theory is Dempster and Sherman, coined by Dempster and Sherman. And in the expectation maximization, Dempster is one of the results. I was just doing with the Dr. Sudha in that time this evidence theory. Then I subsequently changed my mind. We'll apply the expectation maximization. I developed the software, apply it, and in our domain, what happens when you develop a software, you have to demonstrate. When I demonstrate to my professor, H.S. Kurwa, then he understood that it is a very important, one of the important steps of the expectation maximization, the E step, which will compute your Bayesian estimation, having the two conditions given, and then you maximize. And when you maximize, you will come to know what is the below detection. That means the hidden things by applying this technique, when you try to find it out, it must be having some kind of further application. And later on, there itself I find it out. EM, after I did this in 2006, and 2006 I coined that this EM algorithm will be cut into the market. It will bring the data mining. And today, many of the data mining branches is based on that. EM, our mobile like iPhone 6, iPhone 8 has got EM, all the apps has got EM, and it is giving the image analysis in a very beautiful way. Any kind of blurred image by applying the EM you can develop. So this is the EM algorithm that when you do the research, your research should not end. That is the meaning of the you are searching, but you are doing the read. That is the research. You go on searching. Never end. If it never that means it is not a it is a search only, not research. So this is the expectation maximization, initialization, randomly assigned member. So you assign that and this kind of variable with a different domain, and then it gives us the value with that step. Each step you compute this kind of thing with the help of all the information given here, and then in the end step you recompute maximum estimate that, and then finally you subsequently substitute all this formulation, and you get the figure with the proper way and calculate the log likelihood data. You will get the value. And when you do that, your confidence level under this domain will not be done by the standard confidence level. You have to do that in another area called the Akaike information criteria. And since it is a confidence Bayesian estimation, we have to apply the Bayesian information criteria or BIC. So AIC and BIC concept people apply. Whose kind of people apply? Those who are the fishermen. And the fishermen, the science is called the actual science, where there is a lot of statistics involved, and a lot of statistical mechanics is involved, a lot of operation research like branch and bound, cut set, minimal optimization, all these things are embedded. They are all the different branches of AI. So unknown structure, such the initial step, empty network, prior network, operators, and evaluation. Then Bayesian trend summary is that you have the optimal prediction, you have a learner X classification you can do, you can develop the Bayesian networks, and finally you will have a very great algorithm called as the expectation maximization, known as the EM algorithm. And then when you do that, then idea is that how do I learn? Let us try to bring these examples. Any AI book, first chapter is over, second chapter you will see that the hill climbing. Hill climbing is nothing but, and you will see that the fantastic domain, the connectivity of the mathematics. This is the problem that you have just arrived in Washington DC, you are in your car trying to get downtown to the Washington Monument. So it is on the hillside, I have to climb. Can you name some mathematical technique? When I was reading that, then I tried to find it out. It must be connected with some kind of mathematical methods. Because everybody, those who are to the science side or in the engineering domain, we have a good mathematics. In one of the chapters of the mathematics, hill climbing is expressed in a different way. What is that way? When we do that as the improper integral, we apply the Leibniz theorem, method of steepest descent. Okay, if you try to find it as Leibniz theorem, either done the Leibniz theorem or by gamma function if you integrate. When you integrate the gamma function, we try to apply the differentiation under the integral sign. Okay, many of the second year or third year question comes in the engineering domain. And if the question comes, the candidate purpose will do that because he has not understood. So hill climbing is nothing but a differentiation under the integral sign. That's the Leibniz calculus. Okay, and Leibniz is the best jet mathematician after the Newton. So hill climbing is nothing but that. When I found out that hill climbing is nothing but that, then writing a program is nothing but to solve the integral only. So I write the integral. That's all. And then hill climbing is nothing but you see that the various steps, and that is what we call the method of steepest descent. Because hills are there, a lot of crest and trough is there, your legs should not be slipped. So that is the boundary condition that we have to take care of. Okay, so these are the area integral. And what is the learning lesson? You have a global minimum, global maximum, and local maximum. So that means just the hill climbing, we will try to differentiate between the global maximum and local maximum. So when you do that, then we have to go to what the hill climbing is. Okay, hill climbing algorithm, let us see. Pick a random point in the search space. You have to consider all the neighbors of the current state. You have to choose the neighbor with the best quality and move to that state. Repeat that 2 through 4 until all neighboring states are of lower quality. Then return the current state as the solution state, and that's all. So that's the hill climbing technique if you apply. Any kind of complicated integral or complicated unsolved problems can be solved. So again, that you see that these are algorithms function as a hill climbing. Returns a solution state, inputs are the problems, local variables with the current, a node, next a node, and like that only you go on. And following that algorithm, you can solve the problem. Okay, so these are my various results of the hill climbing problem. And then ultimately I showed that A and B you have got a 2 peak, so is it a close good enough? Okay, choose the winning lottery numbers, and this kind of peak you will be knowing that the hill climbing in one of the technique is apparently all our cardiac instruments. When a patient is suffering the heart attack and his monitoring is done by the ECG, and ECG all the peaks are nothing but the hill climbing. Try to match, then I can identify that this is the time domain where the patient has suffered maximum pulse. So heart was blocked that time. So this kind of medicine could be given. And if it is a collapse, then definitely you will have a complete uniform distribution. So by that way, if you write the hill climbing and do that problem, you will be able to nothing but a doctor after some time. That means you are the specialist of reading the ECG, EEG, and MMG. All these enclosed with numbers, you can read that. So this is the close good enough? Is a good enough? Choose winning the lottery numbers, get the cheapest travel itinerary, clean the house. So this kind of concept it will be there. And then finally, when you do that, expert systems can learn. One of the expert systems, those who have already familiar, 1965 to 75, there is a gender. Solve the problem. Mostly this gender developed to solve the chemistry-oriented problem. For example, the x1 plus x2 is a molecular weight, which is given class molecular weight class 28. So x1 minus 20 is a high peak, x2 minus 20 is a high peak, and at least of x1 or x2 is high. Then, if this is the condition, the molecule contains a ketone group, right? So this kind of systems is basically called as a heuristics. So with the help of the heuristics, we can find it out what is the functional group of that molecule. For example, here is a ketone group. So whenever you feed this kind of in a programming mode, and machine will give me that this is a ketone group. Okay, so that is the machine intelligence, or we call it artificial intelligence. how to give this intelligence, that means how to develop the learning technique and develop the memory and so many other things that altogether is called as a machine learning. So artificial intelligence and machine learning, they are just co-brother with each other. So to interpret the rule, we have to have a mass spectrometry. This is a syndrome group, is a functional group, and then we see that the expert system Dendal can solve that. Another expert system is the mycin. Very important. It attaches the probability like numbers to rules. If the stain of the organism is a gram positive and the morphology of the organism is focused and the growth conformation of the organism is plump, then there is a suggestive evidence that 0.7 of the evidence membership, that they are the belief basically, that the identity of the organism is type. That means these are based on the if-then rule. So therefore, the mycin used to call that time as a rule-based expert system. And lot of rule-based expert systems is there with the astrology people. And the astrology people also use Kundli software is nothing but a rule-based expert system. If somebody knows, it's nothing but that. Okay, so when you go for the Kundli software, it gives a lot of questions. A lot of homeopathy doctors solve. They answer the questions. Those questions you feed into the machine, and machine gives as a homeopathy doctor. You need not to go to any doctor. You open your machine and ask this question. You go on asking those things. You see that yes, you give the final result after some 100 or 200 questions. What is the medicine? You purchase that medicine from the shop. That's all. So this is the beauty of the artificial intelligence. Either you can use it as a homeopathic doctor, or you can use it as a Kundli software. Kundli software definitely as an artificial intelligence system. So expert system today is the medicine domain. One example domain medicine, as I already mentioned, that expert system has tasks include arrhythmia recognition from electrocardiograms. You see that the coronary heart disease risk good detection, monitoring the prescription of restricted use antibiotics, early macular diagnosis, gene expression data analysis of human lymphoma, and breast cancer diagnosis. Working the last topic only, I am working in detail to give a good intelligence to early detect the breast cancer. And if you can detect, a lot of patients will be saved. I have already proposed this thing in terms of a good project. I have already proposed to Dr. Sadhana also. I do not know. He has got some family limitations, so may not be able to turn up. So I have switched over to another institute where they are taking this as a serious issue. And I have told them you have to develop the instrument also. And also working with the two hospitals at Pune. One is the Aditya Birla Memorial, and one is our Dinanath Mangeshkar Hospital. So with the two doctors, we are working on this early detection of breast cancer by machine intelligence technique. They have proposed that they will do that. Sooner or later, we will launch some kind of big project. And that was my basically deal that if maybe of the institute could have this kind of course at the undergraduate level itself. So taking the chemistry exam, this is a question. If you read the question that sodium azide is used in airbags to rapidly produce gas to inflate the bag. The products of the decomposition reaction are sodium and water, ammonia and sodium metal, N2 and O2, sodium and nitrogen gas, and sodium oxide and nitrogen gas. And finally, that you answer, get the sodium and nitrogen gas. This kind of questions we feed into the machine intelligence program, which right now we have, that is basically mycin or dendral. It will give the answer sodium and nitrogen. These are system generated answer, like that only it gives. How does the answer came? There is a detail of that. If you read that, you will see that how by heuristics applied you will get on getting the answers. So then comes to the A star algorithm. This is the last algorithm and very important algorithm. It is basically a search problem. If you look at the search, so idea is that when you go for the search, then lot of traversal path is there. So we have to find it out the shortest path. Traveling salesman problem is one of the important problems, right? Our ATM is designed. I have put an ATM machine here and another ATM where it could be. How do I identify? So that if I try to find it out, this ATM is shutter, how do I travel my path to get my money within a short time? So if I look at that particular problem, then we'll find it out that automata theory is nothing but the theory which applies for developing the ATM. And that automata theory, when we apply with the help of that one kind of technique of the computational geometry known as the Voronoi, and then we find it out what should be my next step, where I will travel the shortest path. And the shortest path algorithm is done by this Prince algorithm that everybody knows. And there are many other algorithms. Okay. So this is A star is nothing but the machine intelligence based searching technique. This is the shortest path it follows to identify that blue colored systems we are given. And when you do that, you will see basically you are doing the directed graph or undirected graph. So that means here is the graph theory. Okay. And like this only it is go on taking that path and then find it out that we want this path. And when you go further, there is a node, one node to connected node is the edge and then vector spots, edge and vertices. When you have the edge and vertices, that is nothing but my graph theory. Okay. Not going to the detail because that takes teaching level. Okay. So therefore, we can do that this kind of study that 20 is nothing but the cost of that, then add is the minimum. Okay. So therefore, this path is saying then very famous algorithm, the Douglas algorithm, is a very famous algorithm. A lot of question comes in the computer science domain. And then this greedy algorithm is from the candidate node, select the one that has a path with minimum cost from the starting node. And this kind of algorithm is basically called as an artificial intelligence based technique. Okay. These are the various paths we change following the theory that given a graph, T, a subset of B, the finger of T is defined as this, then finger T, you can find it out that. And why we are interested in our domain, it has got a huge application. Where you know, because if there is an accident takes place, suppose that the Kasab attacked the Mumbai 126-11, right? And then how do I avoid the Kasab so that I will not be killed? If the commissioner Karkare could have known by some machine intelligence technique embedded in his pocket, he could have saved his life. So that is the meaning of the graph theory gives me. When an accident occurs, when a terrorist attack comes, how to follow the shortest path to avoid that kind of thing. So if we can really build up one way virtually, we can demolish the error too. Okay, so this is our technique that's very interesting. So this algorithm is that pick up the edge V in finger, bring the T that has a minimum distance to the starting node, given that the V is minimum. Then it has got a lot of complexity. You can see that whether that is a good complexity means order of that what is the error. And then actually it is bad or very large graphs. These are the various kinds of branching factors. If you look at that, it's good. Details is not required, just to have. So another example is think of the suspect in the case, how to put that the next point. So at a better solution, make a hunch. So that's why I mentioned that the heuristics you have to develop, and a lot of heuristics can be developed just by observing the facts. And then A star search basically gives the use heuristics to guide the search while ensuring that it will compute a path with a minimum cost, and that time only it will test that particular solution. So A star computes the function basically fn equal to gn plus hn, and this gn is fn is the estimated cost, and this function is my actual cost. And this is the way of A star function works. And then finally, A star gets into the games finding. That means pathfinder. So A star basically pathfinder. Okay. Now suppose your son or my son enters engineering college. He wants to find a path to make his career. Whom to ask? If you have a software like that, A star algorithm, you give all your demand. It will be the path, and we call it the pathfinder. And in my domain, physics domain, very early pathfinder was nothing but the Feynman path diagram. So if I do the Feynman path diagram and convert this thing by using this theorem as a machine intelligence technique, then I saw that the Feynman path diagram was really an application path diagram. And using that, we apply it. I applied one of the problems and find it out. It was a problem for the chemical engineering. There are 2-3 vessels were there. By applying the refinement path in our domain only applied, which vessel I should put the more sampling so that the system should be stable. So that was the Feynman path diagram gives me that. And in our cosmic ray Feynman path diagram, we apply in our domain. For example, one of my colleagues is that Tushar. He does the geophysics. That means radioactive waste is dumped into the geological repository. How we bifurcate. And Navier-Stokes theorem or Navier-Stokes equations you cannot solve by using that domain. So we apply a technique. This is also a pathfinder. Of course, we have not mentioned that. It's called as a lattice-Boltzmann evolution. It is based on the physics domain, it is based on the mechanical engineering domain, it is based on the chemical engineering domain, and it is ultimately based on the computer science. All four branches of the science and engineering gives the lattice-Boltzmann. So A star basically solves this kind of problem in one domain. And that's the thing only I wanted to. So I gave the Bayesian learning, hill climbing, A star, heuristics, knowledge discovery, and what are the different routes of AI can be. Thank you.
If any of the people having some doubts or further application, always welcome.
Hello, sir. I am very curious to know whether is it possible to introduce emotions in the machine with the help of this artificial intelligence. Since intelligence is nothing but is not only the logic, it is the combination of logic as well as emotions. Yeah, it's a very good question. That tomorrow you will see that one of my tasks is there called the event recognition. Event is nothing but the action plus the face. If we divide the event into two halves, one is face recognition and one is action recognition. Face recognition, one of the part is the emotion. So very well, lot of work has been developed already, that by which we understand that what is the emotion. Because depending on the emotion, we identify that what action is going to take. For example, that if you do not purchase the train ticket and you see that sticker is there, they will catch you. Automatically your face will change. That means you will be emotional. And your action also will automatically change. Your hand is going to the pocket as if that you are trying to prove that you are just going to take out the bag for your check. This is one example. Very well it has been developed. Another example is that suppose two friends are there. You have gone into a hotel. You have already taken the dinner with that friend, but you are very physically cunning. You do not want to give the money. But still, you will not interested to know your friend that you are cunning. Because in first time, what you will do, general habit is that your woman will go into the back pocket, just pocket out, but you are not taking out. You are making that. This is also emotion. So a lot of development happens. So a lot of programs have been done and developed. Emotion is.
Can this program can be useful for the identification of the bacteria?
Identification bacteria is already done because, of course, not yet. One or two approaches have come because bacteria is a dynamic dependent. Okay, it is not fixed. So the structure identifies every time. Today, if I identify that bacteria, maybe because of there is some kind of reaction, biomolecular reaction, so bacteria will grow or structure will change. But still, people have done that, but still research is going on. And one of the important applications, maybe tomorrow I will try to show you that. That is called the hidden Markov model. By using the hidden Markov model, we can identify the bacteria, like coliform or many other bacteria. One of the main ones is the E. coli.
So, the classifier plays main role. Okay. I think you have explained about the Bayesian classifier. So, obviously, I have to support vector machines. Okay. So, my question is that where I have different discriminator algorithms are there. So, which one is the best one and why?
as on today, the best classifier is the random forest, right? Because support vector machines many people do not like, because inside that support vector machine is a lot of mathematics, and all the mathematics is based on the optimization. So until and unless one is familiar with the optimization technique, and all the optimizations are there is not classical optimization. This is evolutionary based algorithm, like ant colony, bee colony, ESO, and then fish show. So these optimizations many people are not familiar, right? So therefore they try to just elude that part. And maximum optimization technique in the support vector is based on the Kuttaka relations. So Kuttaka relations people never understand many of the time. Okay, so therefore they try to find it out. The some better classifier, and random forest does that better classifier because it is based on the graph theory. So that is why my suggestion is that if you really apply the classifier, you try to apply with the random rather than the SBM or neural network or name. Very well, because all the inputs to in learning technique is not the deterministic, not the fixed. You may have the fuzzy. So fuzzy neural network we have, so we can have that. Neuropathy is the replace. Because when you have the neuropathy, then what happens? First of all, you are taking the deterministic. Outcome may be the error prone. The error sometimes band can be very high. So there we can describe the membership rate to identify it. So neuropathy is better than the body. Yes. I think that people are not having much questions. So I again thank you to the organizer, especially Professor Mandir, to bring me here to share some of my thoughts, because I may be right, may not be right. Until unless we open the market, then definitely I do not know whether I am doing correct or not, or my team is doing correct or not. So my basic aim is to develop a team throughout this globe. Okay, let us hope that we can develop this team first at this foot of this Pravara Rural Education. 2014, I have visited Pravara Medical College. I came here for demonstrating the early detection of breast cancer, and there also I found there is a lot of doctors identify the technique was an unique thing. From that time on, it was my dream. Thank you. May I request to all guests please come on dais.
Thank you, sir, for this knowledge sharing for the participants. Now I request to Mr. M.D. Nirma to do vote of thanks.
It's our opportunity, it's our faith. Today uh, we are here with the great scientists, and it's only because of our Director General, the Vice Chancellor of Lucknow University, Dr. S. B. Nimsi sir. We are very much thankful to Nimsi sir. Because of him, this is all possible. We are also thankful Dr. Devavrat Datta. I have seen one slide over there, and because of my artificial intelligence, I understand it's a Devavrat Datta. In Maharashtra, there is no pronunciation of b. Like might be you all know Devashish Mohanty is the one of the cricket player in the Indian cricket team. Over here in Maharashtra, we call Devashish Mohanty, not Devashish Mohanty. And my artificial intelligence over there applied, and it's a Devurat Datta. Thank you, sir. Your wonderful speech, delivery regarding artificial intelligence, because I have uh, taught the subject of pervasive computing and computer laboratory second for B computer, A star algorithm, greedy algorithm. All these are the part of artificial intelligence, and these are the requirements of today's world. Because now human being wants what the human being wants. Every work should be handled by the machines only, and this is what the requirement of a human being, and the ultimate and absolute happiness the human being wants. And because of the artificial intelligence, that absolute happiness is possible. And Mr. Datta delivered this the knowledge regarding this very well. Thank you, sir. Um, we, the engineering college and the society, Pravara Rural Education Society, also thankful Mr. Argit Chatraj, very good name Argya. We use that name Argya while doing the puja of uh, Surya Narayan. Thank you, sir. Your praise is, we are not blessed by your talking right now, but because of your praises, the staff like us, the age like 30, 32, and 35. Thank you. Your praises is valuable to us over here. The same thing, Sandipan Don. Difficult to pronounce the words, but again, we are thankful, Sandipan sir. Tushar Kantipal. Thank you, sir. Your presence over here, like a, it gives the shapes to us. It's, how you can change yourself from the early years. We are very much thankful, Pravara Rural Education Society. They give the chance to computer engineering department, provides us platforms to shape our life in the artificial intelligence domain. Thank you one and all. Thank you.
Thank you, sir. So here I declare today's session is over. Thank you, one and all. And I inform you all participants tomorrow's session start sharp 10 a.m. in the same room.
Now at 10 a.m.
10 a.m. For the same room. Thank you, sir.